Functional groups. Have you got it? This video quiz will check your ability to identify in skeletal structures some of the functional groups typical of organic compounds, and your ability to describe organic compounds in language that highlights their functional groups. It consists of 3 questions, and it's meant to be taken after you've studied the material and think you understand it. During the presentation, you'll be asked to pause the video to at least try to solve the problems yourself, and only then continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Number 1, find and name 7 different types of functional groups in the structure of the anti-cancer agent paclitaxel, shown below. See if you can remember. Don't look these up. Pause the video while you answer this question. Okay, here we go. First one up, aromatic ring. We have 3. 1, 2, 3. Double bond. If you look carefully, did you find that one? An ether. Okay, again, a little hiding here. Here it is. 2 carbons on an oxygen. Hydroxyl or a hydroxy group. I think there are 3 hydroxyl groups. A ketone. Did you find it? Right there. Ester. There are several esters. Here. 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 And that's it. 4 esters. Okay. How about an amide? We have 1 amide right here. And if you said carbonyl group, that's good because each of these groups, esters, this ketone, all of these esters, the amides, all have a functional group, which is a carbonyl group embedded in them. So how'd you do? Number 2, fill in the blanks with the appropriate words. I won't read this until we have the answers. Please pause the video, see if you can write down all those or think of all those words, and then we will talk about them. Okay, are you ready? Here we go. Some people claim that an alkene has to be a hydrocarbon because it can only have hydrogen and carbon in it. But others say that any compound with a carbon-carbon double bond is an alkene. Chemists are highly prone to use synecdoche. For example, they will call a whole compound a ketone, even though a C double bond O, a carbonyl group flanked by alkyl groups, is also called the same thing. And the compound may have 5 other functional groups as well. But it's not always like that. An OH group is called a hydroxyl by some and a hydroxy by others. But no practicing chemist would ever call a compound with an OH in it that. They would call a compound with an OH group either an alcohol or a carboxylic acid, depending upon what was attached to the OH. Similarly, chemists sometimes use compound names when referring to functional groups. For example, even though an NH2 is referred to as an amino group, in over 5,700 articles in the Journal of Organic Chemistry, there are over 650 articles in that journal that refer to that as an amine group. Go figure. Okay, here's a challenge. A more nuanced and very common example of synecdoche in organic chemistry is the use of functional group names when referring to complex organic compounds as a way of focusing the reader's attention on a particular part of the structure. Here's a snippet from the Wikipedia page for the most famous total synthesis of paclitaxel. Circle all references to functional groups. How are functional group names being used in this entry to simplify the text and help the reader? So pause the video, take a look through this. There's a lot you won't understand, but see if you can pull out the functional group names, and then we'll talk about how they're being used in the article. Okay, let's read this. As shown in Scheme 1, the first steps in the synthesis created the bicyclo 5,3,1-undecane AB ring system of Taxol. Reaction of epoxide 1 with tertiary butyl lithium removed the acidic alpha epoxide proton, leading to an elimination reaction and simultaneous ring opening of the epoxide to give allylic alcohol 2. Okay, so the epoxide is this group right here, 3-membered ring with an oxygen. Now in this particular case, allylic alcohol, that's not a functional group name, that's actually a compound type, allylic alcohol 2. The allylic alcohol was epoxidized to epoxy alcohol 3 using tertiary butyl hydroperoxide and titanium 4 tetraisopropoxide. In the subsequent reaction, the Lewis acid boron trifluoride catalyzed the ring opening of the epoxide, followed by skeletal rearrangement and an elimination reaction to give unsaturated diol 4. Now, this particular use here, unsaturated diol, let's see if we can find it. Here's 4. It says R equals H. So you can see this R up here stands for H in this article. And there are then 2 OHs. So we're going to call that a diol, which is like calling it a double alcohol. And again, it's actually not a functional group name, it's a compound name. It's referring to the fact that this compound has 2 OH groups in it. The newly created hydroxyl group, right, was protected as the triethylsilyl ether. Now, this is a slightly different use of ether, too, because you see this prefix here, silyl. That means that it's a silicon ether. A tandem epoxidation with metachloropurbenzoic acid and Lewis acid catalyzed Grobe fragmentation gave ketone 6, which was then protected as the tertiary butyl dimethylsilyl ether 7 in 94% yield over 3 steps. All right, that's the language that organic chemists use to describe their work. You can see that it's a very complex sort of structure that's being changed little by little into something that they needed for the overall synthesis. They're trying to be very concise. They're trying not to use too many words. And the way they do that is they focus on the functional groups or the compound types. The other thing I want to point out here is this compound 2. You see they say allylic alcohol 2. And this little phrase, allylic alcohol, is a way of referring to both of these functional groups at the same time. That's kind of interesting. And where else do we see this? Epoxy alcohol. You see that? That's sort of a double compound type because it's an epoxide and it's an alcohol. So they can call that an epoxy alcohol. If I had a bromine out here somewhere on the molecule, then I could have called this a bromoalcohol, for example. And then you see, when we see this unsaturated diol, what they're doing is they're saying, oh, look, we're cluing you in that there's a double bond in this molecule as well, not just the diol. Okay, and then one more thing. Notice that when they talk about this compound here, number 6, here's number 6, they refer to simply as a ketone. Well, it's much more than a ketone. It's a ketone, it's an alkene, it's R is H, so it's an alcohol, and it's a silyl ether. But because they want to focus your attention specifically on this change that occurred coming from the previous compound to this one, that where an OH became a carbonyl group, a ketone, they refer to the compound specifically as a ketone. That draws our attention to this particular place in the molecule where the reaction was occurring. So, it gives you a sense of how organic chemists use functional group names and compound types to express aspects of the chemistry that they want to highlight when they're describing their work. So, remember, functional group names are very important components of the language of organic chemistry. We cannot discuss much in organic chemistry without using at least a few of them. You can use many functional group names to refer either to a specific grouping of atoms, like alkene for C double bond C, ketone for C double bond O C, or for the overall compound containing them. The ketone was synthesized from the alkene. However, some functional groups cannot be used that way. They are for the grouping of atoms only. Hydroxyl or hydroxy group for OH, specifically. Alcohol for the compound. But hydroxy compound is okay. You just can't say, oh, look at that hydroxy. You have to say, oh, look at that alcohol, if you're talking about the whole compound. You need to learn functional group names incrementally, just as you might learn words in a foreign language. As you become more fluent, your reading will make more sense and be easier. Don't obsess about this. The key is just to communicate clearly when you need to. And as we go through this textbook, we'll be introducing you to the pertinent functional groups that we will need as we go. You do not have to learn all these functional group names right now. So, I hope that was helpful, and I hope you've got it.